Geometry! Welcome back with the Mastermind channel. Chapter 5, Section 7. Let's get that out the way. There we go. Using congruent triangles. Alright, so the story goes, Napoleon was up against a river with his troops, and he called one of his officers. Monsieur l'officier, he said, oui. Tell me how far is it across the river? Officer said, oui. And he went off and he went to the river. And there he comes up to the river and whoop! And he looked across the river. And then he turned his head and he looked to the side. And then he walked. Doop, 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 doop. And he said, it is approximately 200 feet across the river. And now you're wondering, how did he do it? Well, ladies and gentlemen, the officer made a couple of congruent triangles. He lowered his head so far until the cap met the edge of the river. And so that was the last thing he could see there. And then he turned his head to the side to where his cap covered off the field, and he walked to that point and discovered that was 200, and he had just created a congruent triangle to figure out how wide it was across that river. So, ladies and gentlemen, that's one use of congruent triangles. All right, there's different ways you can use it. Here we could use it to figure out how long is the section, or are these sections actually the same length right here from Q to T, and S to T. Are they congruent? All right, well, we know that this angle right here at 1 is congruent to the angle at 2, and we know that RTQ, this angle, is congruent to RTS, this angle right here. Well, we know that these two, this is what we're given. We know that RT is congruent to RT, reflexive property, and therefore we have an angle here, we have an angle there, and we have a side. Therefore triangle RTQ is congruent to triangle RTS because of angle side. And since these triangles are congruent, we can say that QT is congruent to ST because congruent parts of congruent triangles are congruent. There we go. All right, there's a different method to figure out the distance across a river. So we're going to use this method to find the distance across the river. Place a stake at K, so we're going to put a stake right here, so that NK, this line here, is perpendicular to NP. All right, so we're going to march a line down there. So these two are perpendicular. Now we want to find the midpoint between N and M. N and K, the midpoint being M, right there. And then we want to locate a point L, point out here, so that NK is perpendicular to KL, and L, M, and P are in one line. So I'm going to march this way, make a right angle turn, march this way until I can look across this way and see that this point, and that one all line up. So I'm going to walk with my stick this way and then put it right there. So how does that allow me to find the distance? Well, once I find this point here, I have just created two congruent triangles. How did I do that? Well, here I decided this has to be perpendicular, which makes that a right angle. gives us one angle, the angle at angle N, right? And here we also have a right angle, so that's congruent to angle K. Okay, then we have a side, because we know that this side is the same length as this side, and M is congruent to MK, because M is the midpoint. And then we also know that this angle is the same as that one. Angle LMK is congruent to angle PMN. Why? Because vertical angles. And so now we have an angle, a side, and an angle. Angle, side, angle, hence congruent triangles. Therefore, we know that LK is congruent to NP, which is the distance across the river. That's how we figure that out. Boom. Planning a proof involving pairs of triangles. All right, we want to use this information here and plan a proof. So if I want to plan out to prove BCE, this triangle here, BCE, is congruent to DCE, this triangle here. All right, well, I'm going to need some kind of information, some angles or sides. Let's see what we got. We know an angle here, we know an angle there. So we've got two angles. Can we figure out a side? All right, so we've got this side here. We know that CA is congruent to CA. All right, reflexive property. Reflexive property. Okay, so we can prove that ABC, triangle ABC, is congruent to triangle ADC because of angle side angle. Okay, and therefore we know that CB is congruent, this line is congruent to this one, to CD, because congruent parts of triangles are congruent. So now we have this side, we've got an angle, and they share this side. CE is congruent to CE, reflexive property. Oops, what just happened? There we go, fixed it. Reflexive property. And therefore we have side, angle, side. Triangle BCE is congruent to triangle DCE because side, angle, side. There, I have planned my proof. Now I can write it out neatly and list everything as we need it. Okay, proving a construction. Write a proof to verify that the construction for copying an angle is valid. All right, so let's look at how we copy an angle. So I would use a compass, make a line here, make an arc, and then set it at point D and make another arc. Then I would go to this point, point B, measure that distance, and copy that distance over here. Then I would connect it, and now I'd claim that I've copied the angle. All right, let's see whether that is correct, and if so, why. Okay, so we know these things. We know that AB is congruent to DE. We know that AC is congruent to DF because we used the same arc measurement with our compass. We know that BC is congruent to EF because, again, we measured this and copied it over here. We want to prove that this angle is congruent to this one. So I can list everything I've been given, and then based on side, 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 I know that these two triangles are congruent, and if these two triangles are congruent, then, ladies and gentlemen, those angles have to be congruent because corresponding parts of congruent triangles are congruent. Boom. there you have it. That's all for today. Lots of fun. See you again next time.